Here we are on example 2 from the Coulomb's law section. We have the same 3 charges as the previous problem. 1 microcoulomb for A, it's positive. A negative 2 microcoulombs for B. Positive 3 microcoulombs for C. All right. There's one interesting thing about this setup. 1 centimeter, 1 centimeter, 1 centimeter. This is not just an isosceles triangle, this is an equilateral triangle, meaning that this angle is 60 degrees, this angle is 60 degrees, and this whole angle up top is 60 degrees, but more specifically, this angle is 30 degrees, and this angle is also 30 degrees. That is going to be really helpful for us in just a moment. Okay, so the setup is drawn. Boom. Trigonometry has been noted. Boom. What's our system? We are looking for the net force on C. Okay. C is experiencing 2 forces. It's experiencing one force from A. They're both positive, so that force is going to be pushing it away. It's okay to overlap the text a little bit. Force of A on C. Next. B is also applying a force, but that force is going to be twice as large because B is twice the charge that A is, and they're the same distance away. So B is going to be attractive, positive and negative, and the force is going to be twice as much. Force of B on C. All right, system identified, forces drawn. Next, use trig and Coulomb's law to determine components. I'll start with f of A on C. Just the magnitude is going to be K QA cube C divided by R squared, which is 9E9 times 1E negative 6 times 3E negative 6, all divided by 0.01 squared. Grabbing my calculator, I get there's a 3 and there's the 1. I get 270 newtons. I want to break this down a little bit more. Okay, this is 270, and it should be parallel with this line right here to be a nice repulsion. That means that this angle here and this angle here are both 60 degrees. So in the x direction, that's going to be 270 cosine of 60. Gives me 135 newtons, and that's to the right. And the y part is going to be 270 sine of 60. which is a bit of a messy number, but I'm going to round it to positive because it's upwards, 234 newtons. Okay, so A on C is going to be 135 newtons in the x direction and positive 234 newtons in the y direction. Let's move on to Beyonce. Most powerful force in the music industry. Force of Beyonce, magnitude, is equal to K QB QC over R squared equals, this is going to look a lot like the previous one, 99 times 2e negative 6 times 3e negative 6 divided by 0.01 squared. Gives me 540 newtons. Directionality of this stuff. Earlier, I'm going to zoom in. I said that this here is 30 newtons, 30 degrees, I mean. Therefore, this is going to be 60 degrees because they're complementary angles. But it's below the x-axis, so I'm going to call it negative 60 degrees. So to break up f of b on c into components, I'm going to get the x part will be equal to 540 cosine of 60, negative 60, and the y part will be equal to 540 sine of negative 60. So 540 cosine of 60, negative 60, gives me 270 newtons. And the y part, 540 sine of negative 60, gives me negative 460, I'm rounding this to 8 newtons. Taking those, plugging them in, plus 270 newtons and negative 468 newtons. Those will add up to the net electric force on C. Okay, 135 plus 270 is 405 newtons, and then 234 minus 468 is negative 234 newtons. So we're getting something that is very much so to the right and down. Looking at this, drawing a little parallelogram out of it, yeah, I get a result that is very much so to the right and down. That works. Trig's good. Adding like components was good. Double checking the result. I'm going to double check it. I'm also going to do it one more way. What about polar coordinates? In polar coordinates, the magnitude of the electric force on C is going to be equal to 405 squared plus 234 squared, square rooted. 405 squared plus 234 squared, all square rooted, gives me 467, round that to 468 newtons. At an angle, That'll be the inverse tangent. We're in quadrant 4, so I don't have to worry about the quadrant after that. The y part, negative 2, 3, 4, divided by the x part, 4, 0, 5. In general, I only worry about the quadrant if I end up with a negative in the denominator or a 0 in the denominator. Inverse tangent of negative 2, 3, 4 divided by 4, 0, 5 gives me negative 30 degrees. And that fits with what we're seeing up there, where it's basically in that direction. About 30 degrees sounds right. With a, I'll draw the 30 degrees there. And the magnitude is 468 newtons. Okay, this was a harder one. This one, there was a fair amount of trig that had to be done. Everything had to be broken down into components, so just be aware of the trigonometry, and that's why we draw these things, so it's easier to see the trigonometry. All right, one more example to go.